In this video, we're going to take a look at slopes of parallel and perpendicular lines. So first, let's write out parallel lines have a slope that is the same as the other line. So they have the same slope. And they look like they will never touch because they won't ever touch. So they're running like side by side, kind of like railroad tracks, and they have the same slope. Where perpendicular lines have what we call opposite, because the signs change, and they are reciprocals of each other. So they have opposite reciprocal slopes. And these lines look like they cross to exactly form 4 right angles. So they form 4 right angles when you have perpendicular lines. But we're focused on their slopes right now in these notes. So we're going to identify an example, the first set of examples, we're going to identify the parallel and perpendicular slope for each of the following. So in the first example, we have the slope of 2/3. So the parallel slope to that would be 2/3. But then the perpendicular slope to that would be the opposite, so it's negative, and then the reciprocal, so it's 3/2. In the next example, we have -4/5. So the slope parallel to that would be the same slope, but then the slope that is perpendicular to it would be positive, and then the reciprocal, which would be 5/4. And then in the third example, we have the slope of 4. So the slope parallel to that one would be 4, and then perpendicular would be -1/4, because 4, if you had to write it as a fraction, would be 4/1. All right, so let's look at some examples that are various things you might see with these problems. So number 1 says find the slope of the line parallel to the line 3x minus 2y equals 4. So what I can do for this one is pick out my slope, and my slope in this case is -a/b. And so what I mean by that is this is in standard form, which is ax plus by equals c. And so my a value is 3, and my b value is -2. So my slope is going to be -a, which is -3, over b, which is -2. And then I just need to clean that up a little bit because they're both negative. It'll become a positive 3/2. So my slope parallel to this line would stay the same. So my two lines would both have a slope of 3/2. All right. The other way you could solve this is you could solve for y. So let's look at this another way. So if we have 3x minus 2y equals 4, and we want to solve it for y to put it in slope-intercept form, we can move the term that has x. So let's subtract 3x from both sides, and we bring down -2y equals -3x plus 4. And then we got to divide everything by -2 to get y by itself. So then we got y equals positive 3/2x, and then 4 divided by -2 would be -2. And then once again, you can see that your slope is the 3/2 that we found by doing -a/b. So either way, you get that slope, and then the parallel line to it would be the same. Let's look at another example. So if we want to find the slope of the line perpendicular to this line, so remember in standard form, ax plus by equals c. Let me scooch this down. Your a is the 4, your b is the 5, and your c is the -15. So to find a slope quickly, you can always pick out -a/b. So in this case, that's going to be -4/5. So see how nice and easy that is? But the other thing you can always do is solve for y. So if you're real good at solving for y and you like to do it that way, that would also work. So I'm going to bring it down here and solve for y. So I'm going to move the x term to the other side to isolate the y term. So I have 5y would now equal -4x minus 15. But then I got to divide out the 5. So I end up with y equals -4/5, and then -15 divided by 5 is -3. Oh, and I need my x beside my slope. So notice I get the same slope solving for y that I did by picking it out of my standard form, But the line perpendicular to this line, remember, would be the opposite reciprocal. So opposite means you got to change the sign. So if it was negative, you got to make it a positive. And then reciprocal slope, so that means you switch the fraction around. And so the 5 has to go in the numerator, the 4 in the denominator, and it's a positive because it was negative. So that would be the slope perpendicular to this line. All right, let's look at another example. This says write an equation of the line parallel to y equals 3/5 x minus 4 and passing through the point 5, 1. So if we only want the equation of a line parallel, we have the same slope, so that's nice and easy. Since this is in y equals mx plus b form, then the m is right there. So the slope we know is 3/5. And then it's passing through the point 5, 1. So let's use those numbers for x and y. And we got to figure out the y-intercept. So y equals mx plus b will help because we can say y equals our slope plugged in for the m. Our x is going to be the 5. The y we can replace with this y over here, which is the 1. And we're going to figure out the b, which is our y-intercept. So we have 1 equals... And then the 5, I'm going to rewrite it as 5 over 1 so you can see a little bit better that the 5 is in the numerator and the denominator, which makes those cancel each other out. And then we just end up with 3 plus b, and then we have to subtract 3 from both sides. So we get -2 equals the b value. And then our final equation would be y equals mx plus b. We have the same slope, so that'll be 3/5 x. So y equals 3/5 x, and then the b value was -2. So that is our final answer. It took a little bit of work, but nothing too crazy. Let's look at another example. So number 4 says, write an equation of the line parallel to y equals 3x plus 9 and passing through 2, -6. So our slope would still just be the 3 right there. And then we have our x value and our y value that'll help us find the b value. So let's use what we've been doing lately. Y equals mx plus b. Our y is -6. Our slope is 3. And our x value is 2. And we're going to solve for the b. So we'll bring down -6 equals 3 times 2, which is just 6, plus b. And then we got to subtract 6, so we get -12 equals b. And then we just got to write it all out together. So y equals mx plus b. I got to make sure I'm getting the right slope. So it did say parallel, so my slope did stay the same. So y equals 3x minus 12 would be my equation. All right, let's see. Number 5 says, write an equation of the line perpendicular to y equals 5x plus 3 and passing through the point -10, 8. So what I'm going to do this time is pick out the slope, which was 5, but perpendicular to that, so think 5 over 1, the perpendicular slope would be -1 over 5. So that's going to be the one I need when I plug it in to find my equation. So I'm going to plug it in with my x value being -10 and my y value being 8. So let's do y equals mx plus b again. The y is 8, the slope is -1/5, the x is -10, and then we're solving for b. All right, so we just need to clean that up. We've got -10, so let me move that just up a little bit and put a 1 underneath because that means the same thing. But then we can see that like the 1s would cancel out and we have -10 over -5, 2 negatives, and then we still have plus b. Then -10 divided by -5 would be +2, and bring down the b. And then we need to subtract 2 from both sides, so we get b is equal to 6. So the equation of the line perpendicular to this line would now be y equals mx plus b. And I'm going to fill in the slope is -1/5 x, and the b or the y-intercept is 6. So that's it for that one. Let's just look at one more example. So number 6 says write an equation of the line perpendicular to y equals 3/4 x plus 1 and passing through the point 6, 3. So the slope of this line is 3/4. So the perpendicular slope to that would be -4/3 because it was positive, so we got to change the sign, and then we have to flip the fraction around so that the 4 is now in the numerator. Then let's plug in the x is 6 and the y is 3 to figure out the b value. So y equals mx plus b. The y is 3. The slope is -4/3. The x is 6. And we're looking for b. Then again, I'm going to scoot 6 up to put it over 1 because that means the same thing. And then I can simplify. So 3 would equal, and when you have a fraction where they don't just cancel as easy, you can multiply across the top. So -4 times 6 would give me -24. And then at the bottom I have 3 times 1, which is 3. And then -24 divided by 3 is -8. And then I have the b still that I'm looking for, and I just need to add that 8. So 8 plus 3 would give me 11 for my b. So perpendicular to this line would be y equals mx plus b. My slope is -4/3. And then I have x, and then I found my b value was 11. All right, so that's it for lots of good examples of what we could be asked about parallel and perpendicular lines.